Greetings and welcome back. Today we'll be looking at reduction of alkenes and alkynes. In the last video we looked at reactions in which we could start with pi bonds and add bonds to oxygen. So for instance we ended up adding things like diols, where you replace that pi bond with two bonds to oxygen. Today we'll be looking at reduction. Reduction is where we start with an alkene, and instead of adding on multiple bonds to oxygen, we add multiple bonds to hydrogen. And so the reactions we'll be doing today involve adding hydrogens to both sides. So if we want to add hydrogens to both sides, believe it or not, the reagent that we use to add two hydrogens is H2. Hydrogen gas put under a whole lot of pressure with a metal catalyst. In particular, we use usually platinum or palladium. You don't have to use both, just whichever one you have on hand, is going to add two hydrogens, and it adds hydrogens in together. And so what we will do is convert that alkene into an alkane by adding two hydrogens together. And that's reduction. So this, as you might notice, is syn addition of H and H. And that's how we do it. If we start with an alkyne and add pressure by forcing in a whole lot of hydrogen gas in the presence of a palladium or platinum catalyst, we will do this twice. And because we have two pi bonds, we can add on two hydrogens to each side, or four hydrogens total, and we will get double syn addition of H and H. Unfortunately, if you just add in pressure and hydrogen, you can't really stop this reaction from happening. The hydrogens are just going to go on everywhere. But a really cool thing that we figured out how to do is if we want to start with an alkyne and turn it into an alkene, we have figured out ways to do that. So if you want to start with an alkyne and basically stop halfway through, that is to say, add just one hydrogen onto each side and end up with an alkene. So in effect I'm saying going from here to here. Then the way that we do it is, it looks the same. We would use pressure and hydrogen and platinum or palladium, but we effectively have to poison our reagent because we don't want it to add to both pi bonds, just one pi bond. And so the way that we do this, and we literally call it, we basically poison this so that it can't react twice, and chemically we do that with one of two different things. We can add barium sulfate, BaSO4, or Lindlar's catalyst, which is quinoline. Quinoline is a really cool molecule and also a very cool word. But Lindlar figured out that you could do this, so we often call this Lindlar's catalyst in his honor. So this is three reactions right here, but they all look very similar. So if we start with an alkene, we can add a hydrogen to both sides, which breaks our pi bond. If we start with an alkyne, we can add hydrogens to both sides twice by breaking both pi bonds. Or if we choose to poison this reaction, we can start with an alkyne, which is two pi bonds, and only add hydrogens once. They will add on together, so once, of course, this will be syn addition again. But if we poison this guy with either barium sulfate or quinoline, we can make sure that we're only adding hydrogens on once, and we would stop at the alkene. So I'm going to write these names in really quickly, and you can think about any questions you have to bring to class. So this would be an alkene turning into an alkane. This would be an alkyne turning into an alkane. But if we poison it, we can turn our alkyne into an alkene, specifically a cis alkene. Thank you very much. I hope you thought of questions. Please bring them to class, and I've got one for you right now. Take good care, and I'll see you soon.